Hi, welcome to the part 3. So at the last video, part 2, I've dropped at NLTK, and I told you that the installation, these much commands are needed for installation. This is the page for speech recognition, but let's back to, so these are just going to install the library at your in your system, but you still need some packages which actually going to help you to work with. So not to worry, this two lines it's actually going to help you with uh, the downloading will be a big files, so it may depend upon your internet speeds how much time it's gonna take. Like it may start with 15 minutes, may done in 15 minutes, and may take like 2 hours or 3 hours. So what you're gonna do is there is a built-in downloader that we have in NLTK, and we're just going to use download. A download will help you to do it terminally. We have an option for I think GUI, but I guess it won't. I don't know, but it doesn't work on my system. It will give you a GUI that actually does work in Windows if you just simply go with NLTK downloader. It's going to give you a GUI, then you're just going to select all packets and then run. But I'm just going to show you with the terminals. So you can do it within the ID. It's not a problem. I like PyCharm because of that also. So, so let's running this, and it this will come to you. And what you have to do is you need to download it. I guess D will work, and then you need to ask for the list because you're not sure. Though if you type all and press enter, it's going to download all. This is what even I used to go with. So even for satisfaction, we can put L. It's just going to read the packages from the website and it's going to give it to you in front of you. So that's gonna take time. So once this is done, I'm gonna resume it again. So, but actually, I've already installed it. It doesn't show me all the packages. These might be the recent packages that shows up. So yeah, that's a problem. But if you simply type all, it's going to start downloading. Just simply say all and then hit enter. Done downloading collection all, because these are already there in my systems and these are this much, right? So yeah, it will take time for you depending upon your internet speed, but once these are done, then we're good to go. Your NLTK is all set, and then we can jump to the different sections of this tute. So once you're done with that, congratulations. And right now I'm just going to stop it because it will be thinking about the next command like update. You can go ahead, config if you want. I haven't done it yet. So I'm just going to close this file and let me minimize this. So uh, these are the two files which actually helped me to build what I showed you in the demo. Um, so let's start with this. So I told you that we need Buckets Phoenix, and then we need um, China Convo Convo DB. So it's like conversation DB. This is this file that I'm trying to import it here, and then speech recognition simple, which I'm going to work with SR. So speech recognition for online, Pocket Phoenix for offline, and this module is just to interact with the DB. So I've already explained you what all I've done in the DB. So I'm not going to jump into the left side, which is actually the initial stage of this, but I'm going to tell you how DB is working on. But if I talk about the overall logic, so this is, as the name says, it's offline. So it's basically checking the phrase with the live speech that I'm going to speak, and whatever it is, I'm going to print offline. Print offline because whatever text it is there, it will first say offline, and this text was actually detected. So offline, the phrase that is detected, I'm going to convert it into a string and then put it as printed. Then I'm going to cross check like if it does contain the keyword, and if it does, then go to the database, cross check, and then come. come back with a response to it, and then we're going to cross check with the match. The match is basically going to wait for the command that you're going to give, and once you give that command, it's simply going to uh, getting the keyword the response giving to the keyword shine a keyword, and this keyword it's doing nothing but going to the database, cross-checking that response, getting a reverse back. This is one thing. So this will jump to this file. Now there is one more file that I haven't opened right in front of you, which is important too. So I think this is this one. Yeah. So this is speak where I have used Google Speech, and I told you about NLTK, so the tokenizer that's going to send tokenizer, and there is one more word tokenizer. So word tokenizer I don't want to give it because it's going to speak one by one. Hi, my name is. I don't want that. So I don't want my name is that kind of thing. So send tokenizer is going to help you with that. Then the random select one of the choices that I have. Okay. So these three files that we need to work on, and this one. So I guess the basic is this one. We'll start with this one. If I start explaining this one, that's gonna help you with understand what we going to work with the conversation DB, and once we are did with that, then we can come back to Pockets Phoenix where the exact thing is working on. So this is basically going to help you to give a speech to your system. What we are actually doing is it's going to accept some message. This method need a string that need to be passed to it, an object, and then what we're doing is, as I told you, in our DB we have used an or symbol, which it's going to give that, which is going to say, okay, one string is done, and the or symbol is there now. So we're going to split the message that we receive, and then give a random choice among them, put it into a message file, message variable, and then we're going to do a send tokenize message for this message. For every sentence that we have in the message, every sentence is passed to it. I'm going to print it to get a proper response. Then I'm going to this is basically Google Speech package. So socks we define to give a better way to speak it out. It's socks effect. So the default one seems to be very slow, so I use the speed basically to improve it. So speed one, and then in this we are just going to pass two variables, the language and the message that we want to speak, and giving them as defining a socks effect, and then we're going to use same variable to play with these socks effects, and it will be played out. This is what we actually were now. So let's try with this. It's just going to speak right now. It's not with the speech recognition. So anything that I'm going to speak, it's not going to work on that. It's going to work for this. This is a test method that I've created. Basically created a text, and then it pass it to the method. This text will go to message, and then this functioning will happen. So let me drag it a little bit. Yeah. So you see, our symbols are there, right? So one will be detected as a single, and then it's going to work. So let's run this. And a random choice will be there. So
Not too bad.
yeah, so it's a random choice. It's gonna work for one by one, right? So in this, it's like this one, not too bad. That's all. Now, how about if I give an introduction? I have, I guess, an introduction. This is the introduction string that I have. It has full stop. Now, some may say that rather than using an or, why don't you do a full stop? Because send tokenizer, then even send tokenizer is not needed because it's a full stop. No, a single response can have multiple sentences. In that scenario, it's better to have a or sentence because your string will never have a or in in it. It's way better this way. So let me paste it here. So we have a new sentence now with with the dots. Now, why I'm using this? It's first to show you that it's going to convert sentence by sentence. First thing. Second thing, we're going to print each and every sentence, so it would be easy for you to see that one sentence has been in the entire string. One sentence is took out, grabbed from that sentence, and then it is going to speak that. That too, the speed will be way better if we don't use send tokenize. The speed will be low. If we use it, it's way better. So let's run it.
Hey, my name is Chayana. I have ears and shivers working on my eyes. I hope we will see each other soon.
So this is like this introduction was created before face detection I did. So it's an old one. I know I needed upgrade for that, but this is how it is. Like, hey, it's detected as one. Then my name is Shana. This is detected second sentence. Then I have ears and shivers working on my eyes. That is fourth sentence. Third sentence and fourth sentence. And if we speak one by one, it looks way better rather than just passing the entire string into it. Because the full stop actually give a pause when she is speaking, and that pause is not needed because full stop is not actually a pause, but it will be converted as a pause. So that is not good. That doesn't look a natural way. So this is the first file. So let's call it a part 3, I guess, of this. But this is how it should work. So NLTK and random and Google Suite. This is the role. These three model have this role, and this is how you can simply work on. I'm going to comment it out because I don't want to affect it in a second. So yeah, that's all. Thank you.